Okay. Hello. Welcome to the stream. Hello, Rage Kit. Nice to see you. Just preparing a bit. Uh, okay, so thinking about what needs to be done. Wheel spin, right. Compile error fix. All right, yes. Assets. Okay. Yeah, I forgot to share it on my Discord. Just a moment. Whoops. I can't directly share. Okay, wait a minute. Okay, here it is. Okay, so everyone, welcome. Oh, I disconnected from chat, unfortunately. Okay, now the chat is on. Hello, everyone. Whoops. Does it work? The sound is fine, yes. I accidentally knocked the cable. Okay, so let's begin. Today, yeah, so what first of all, I need to remember to talk a little bit about the game. So, what is it? What's going on, and what is this stream about? Well, it's I'm working on the game called Shakedown, which is a rally game, very simple, made in a custom engine. So everything you see here is custom, well, except for the libraries, a few libraries. But yeah, I don't have an editor. I don't have. I just have this. Let me show you. Okay. Yeah, there's a lot of warnings. Oh, right. This is Bullet's problem. So yeah, here's the game. So oh shit, yeah, I forgot that I didn't load the config. I need to go to the config and change this. I'm not sure which one is it. Release or this one? No, this is the one that runs from inside. Okay, yes. So this is the one that runs from within the Visual Studio, because there's two different. Yeah, it depends where you start the game from. If you start from Visual Studio, it will use a different config than if I start from a standalone built game. Okay, so Even my starting position is fucked. Okay, well, yes, I totally forgot to return to the old one. Okay, well, let's try to actually run it from here, from release. Maybe I have the start position here. Correct. Okay, it is, yes. So here's the game, right? You can drive around. And what I did yesterday is, whoops, sorry. I just passed through the house. Interesting. I thought that it should, oh, maybe I kept the tree. Because if you put a tree inside an object name, then it will not be added to the collision physics. So yeah, maybe I did that. I'm not sure. But anyway, here's the game, and this is the little town that I was working on the previous streams. This is the church that I worked on yesterday, and found a really good place there, so that you can, when you're driving around, you can actually see the backside and kind of like try to hit as close. The church is collidable. That is good. So yeah, you kind of need to find the place where you're so that it's like a hair width to pass for best times, which is nice. But very dangerous because you can damage the historical monuments of my game. Anyway, yeah. So this is the town that I was working on the past days, and still not finished. But I do have most of the houses. Some houses are missing their shutters. There's only one shutter on one side. But yeah, these are more representative houses. These over here, which do have shutters, and this one over here. And yesterday I was adding these windows, and yeah, I think either tomorrow or on Sunday I'm gonna finish the town, and then hopefully finish patching up all the holes of the all these holes that you can see here. And I'm probably not gonna do that on stream because I need to be fast. I need to finish that as soon as possible, and it's kind of a not a very interesting task. Whoops, I hit. So yeah, I think I'm gonna do that later, outside of the stream. Like just patch up all the holes from the track, everything that's missing. The nicest part so far is actually the mountain, because it's not nice because I forgot to rebake here. Yeah, the only tunnel I rebaked is the lower one, and I didn't rebake these, so that's why they have this black outline. But yeah, this is the most patched up area, no holes here. But as soon as you go out on the other side, there are some holes here, and there's a lot of little holes inside the tunnel. It all needs to be welded together. And then I even this road is completely fucked because it has like overlapping faces, which I need to solve, which I need to fix. And I have to do it vertex by vertex, basically. Yeah, and then there's also this giant hole, which sucks because whenever I take photos of the town, there's either this hole or this hole visible here. But yeah, once that's patched up, there's just a few props to add and some trees as well. I don't have any trees here. I used to have some trees, but now they're not there. Yeah, I need to add some trees, and that's about it when it comes to the track itself. But what do I want to do today? So today is going to be a little bit different. So the thing is that I want to improve the driving physics. And why do I want to do that? because it's right now it's totally fake. So it's not even using. So it's kind of like the uh, the car is more like a rocket than a car. So basically, there is like a constant force being pushing the car. So it's not even using tires, or it is, but it's kind of super fake. It is only calculating the how much the engine is spinning and how much force it should give, and then I just push the whole car forward. So it is kind of in that sense, but it is unrealistic. But there's no real calculation of tires, so tire spin. And as you can see, the tires don't even spin, and you probably didn't even know that because I never show them up close. And from far away you can't even see. But yeah, the tires are not even spinning. They are rotating, as you can see here with the steering, but not spinning along the horizontal axis. So yeah, that's the first thing I want to do is I want to make them spin. And then when I have the graphics of spinning, I can easily create. So yeah, basically what I want to do today is I want to add a more realistic spin mechanics, so that using a more realistic Patseka based curve, and basically the classic tire dynamics that uses the slip ratio. But for the horizontal forces, I am actually going to keep this the thing that I already have, because I kind of like it. I kind of like how it feels, and I don't want to ruin that. I just want to improve the longitudinal force. And another thing is that the brakes are kind of fucked up completely right now, because if you increase brakes, if I increase the brake multiplier, you can see that if I press on the brakes, it kind of digs into the ground, and it doesn't stop linearly. It actually, like, there's a weak braking force in the beginning, and then it ends up with a very strong braking force that like kind of digs in. But it should be the deceleration should be linear, more linear, like in real life, rather than like how do you say this, exponential, sort of. Although it's not precisely exponential, it's just weird. It's like really weird. Okay, anyway. Yeah, so the thing is that yesterday I made a little rig in Unity. I'm gonna show you that. Oh, this signing is so annoying. It wants me to sign in the Visual Studio. So yeah, let me open up a Unity. It was just the reason why I was using Unity is just a lot easier to experiment with. Yeah, this is gonna take forever. It's gonna take forever to start. One wheel project. But yeah, the reason why I wanted to use Unity was because I thought a compilation script is gonna be faster. It's gonna allow me to prototype in a faster way. But actually, compiling C# code takes so much time nowadays. I don't know. It's the new Unity versions and stuff. It sucks. It's getting slower and slower. And yeah, I thought that the new versions would be faster because like they add a lot of new optimizations, and even they were in some new blog post they were even talking about how it got faster and faster and compilation speed is a lot better, but nope, it still doesn't feel very fast. So what did I want to do? Yeah, so I wanted to show you how the physics works. Not this physics, the other physics. physics car. So yeah, the physics right now are very fake, and you can see here, that when I'm actually applying force, yeah, this is the end resulting force, and I do that through two different functions, one for forward and one for sideways force. And the forward force is using simply this multiplier, the acceleration that I want to have, traction factor. Yeah, that's something that is like, traction factor is just like the number of wheels touching the ground, basically. And then what I do in this function is actually just multiplying everything. So forward by acceleration multiplier by the factor, so how many tires it hits. And then the sideways traction force is a little bit more complicated, but I like it, so I'm gonna keep it. So as you can see, it's just totally fake, and there's no wheel spin. It's just acceleration impulse, which is just calculated directly from the keys that you press. So, and the acceleration multiplier, it does actually depend on the gear you are in. So there is some physical sort of effect, but not anything realistic. Okay, well, the Unity has finally started, and you can see here I have this one wheel. If I play the game, I can spin it forward, and it will roll, and I can spin it backwards. It will roll. I can stop it suddenly, and it will like affect the force and stop. So this is sort of what I want to do in my game as well. Oh, it's going. Yeah, it is completely. This is not physically simulated at all. It's pure code. So it's pure, like, not using anything Unity's except using the transform. So basically it is the classic slip based way of doing tire traction. So yeah, let me show you the code. Yeah, now we're gonna wait for 2 hours for the Visual Studio to start. Okay, so yeah, basically what I need to do first is, so this is the to-do. Since last, I didn't actually show you what I did since last time. I added a, so you remember that I had this problem when initializing meshes, that I always had to resize the mesh size, mesh capacities. Well, now you can resize mesh capacities in your game, not in the engine. And you do that by, where is my initialization? Particles, no. Okay, it is here. So yeah, before I load everything, there it is. I start the engine and I initialize it. But before initializing the engine, I actually now can set initializing parameters for assets. And for example, here I'm using a default struct, but I'm only changing the mesh's capacity because that's the one I don't like. And I discovered yesterday that there's this thing in C++, which I have no idea how it's called, but you can actually define a dot something, right, if you want to change. So because this init parameters thing is actually, it has 5 members. So if you create what is the type again? Asset manager init props. Yeah, the autocomplete is so slow. If you have init parameters and you say some, I don't know, params, and then you open, and then if you do that, it will initialize to the defaults. Actually, I think that for structs you can even do this, and then it will, so it won't be uninitialized. because I'm initializing them in the struct itself. And then you can do this params. For example, so this will create a default one, and I still like to do this just to make sure that it will initialize. And then for each of the members, you can do, okay, different audio clips capacity, materials capacity, whatever. But now in the C++ 20, I think, what you can do is that instead of this, you can put these in here, and then just have that. And you do have to use the braces initialization. So we can just do this. Right? Why does it complain? So slow. Yeah, it's so slow because I think I opened the other the other project. Huh? What does it say? Error constant. So it's not like that. Do you need to use a that? No. Okay, well maybe it doesn't work like that. Well, it does work here. Can I add this? Okay, so it works. So what am I doing wrong here? It's the same. Is it just IntelliSense? Maybe it's just IntelliSense being stupid. I'm gonna assume it's IntelliSense being stupid. But yeah, anyway, you can do that now. So what I'm actually doing here is I'm creating a new struct of init params type, and then I am only changing this as the default. So yeah, I am, in this case, I'm using the default engines parameters initialization capacities, but I'm changing, I'm increasing the meshes and also the physics. And now when I call init all, it will actually initialize parameters with these parameters, which is cool. So yeah, it's much easier, and you don't need to initialize each point of the engine. You know, it can do it for you now, which is nice. Okay, so more struct properties and less weird function parameters. I actually much more prefer now using like separate properties than actually passing them into functions. Okay, so let's go back to tire physics. So this is what happens. This is what's happening in my in Unity. Okay, let's go back here. Oh, right. Well, the Visual Studio was probably slow because Unity was running in the background. Yeah, so I can spin the wheel. I can stop it using sort of these simplified Pateika formulas. And yeah, so what I'm doing here, I'm just using the key codes to, the keys W and S to spin the wheel forwards and backwards, so there's no engine simulation or anything. But here I'm calculating the this is this is not used. Okay, I'm rotating the wheel by the wheel velocity, which is in radians. And then I have the the ideal is just, how much the sort of the linear, how long does the wheel move if by certain rotational velocity, right? Which is just rotation by radius. And then I calculate the slip ratio with this formula. I used to use this formula, but it had more errors than this one. And this one also gives me the sign. So yeah, it does actually work better. And then I have, yeah, I am actually checking is nan here because of course this velocity can be 0. So when the velocity is 0, then everything breaks down, right? Although it shouldn't be nan ever because I already have this check. I forgot to put the check. So, and then for the longitudinal force, I am using the simple Potseka formula, which I just given some default parameters. And then this is the formula that is the that gives us the magic curve. And I got this actually from a I got this from Eddie's formulas. Yeah, here it is. So Eddie is the guy who is making the vehicle physics for Unity as plugins, but he wrote some nice blog posts about it, and he's explaining some things like the slip ratio and the slip angle, which I did know from before. I've been fooling around with the vehicle physics for a very long time, but he does show in this other blog post called A Comprehensive Guide to Potseka. He is talking about all the parameters that goes into it and explains the different the different years that it was done in, because every new Potseka formula, because there's different generations of it, and each new is adding some more parameters. But actually, for the sake of the game, you don't need any of these. You can just go to the bottom and then see, okay, there's a simplified magic formula, which has just constant coefficients. So it doesn't have a lot of things like camber, and yeah, so this is the one that I'm going to use. And here it is, this is the formula. So that's the one I'm using here. And what I already did yesterday is I rewrote that for into C++, sorry. So if you go here, you can see that I've added this Potseka simple. I'm just not using it anymore yet. So now I want to use it. And the way I want to use it is, so basically I'm calculating the longitudinal force. I forgot to say that, from some random force. And then I'm also have to multiply, because this wheel basically has 1 kilo, right? This one. So I do have to multiply it with the weight. And then, in Bullet, I'm gonna tell you a secret. In the Shakedown game, the car also has 1 kilo, because I just don't care about weight. So yeah, you can't really plug in real equations. You would need to just multiply it with the weight, with the real weight, or divide. So transform position, and then I'm just moving the position by velocity, and that's it. So basically what I want to do is I need to use this and then copy it into my engine. But first I need to make the wheels spin. How do I do that? I need to find, there it is, update wheel graphics. Okay, let's make the wheels spin first. There it is. There's our rotation. So for each wheel, graphical position, I know where it is. Position equals, okay. Rotation is, okay, so that's the base rotation. I see. I remember this. So yeah, this is because there's those on the left needs to spin in one direction, and those on the right need to spin need to spin in the other direction. And then also, if I is less than 2, these are the ones that are that are steered. So that's how I actually pick which wheels are steered and which are not. But yeah, so I have this rotation, right? Let's see what is going on here. This is axis based, right? Rotation. So what if I multiply roll angle? Oh, I do have some kind of roll angle. Oh. Okay, I did already try, obviously, to add some roll. And did it not work? Let's try. Oh, but I'm setting it here anyway. So let's try multiplying. Does multiplying quaternions just works in GLM? Or do you need to... Okay, let's see. What happened in main? Ah, yes, I was showing this. So let's just revert to the beginning. Okay. And you know what? I'm gonna use the other track. This one. Okay. So, as you can see, the rotation is totally weird. Nice. It's very Back to the Future now. I see. So it's completely, I think, independent from the car itself. Nice. So I do think that you need to have a base rotation and then add to it. So I guess I'm just not doing that, am I? I don't see a problem. Hello, Buan. No, yeah, there's no problem. I don't think there is. It's working perfectly. Okay, so let's see what's going on. So yeah, here I do have a base rotation, right, which is this. So it is the forward and up from the car. And then what is this pi for? Oh, that's the angle. I see. Oh, yeah. Oh, that's because I am calculating it. I'm rotating it 180 degrees. That's why. Yeah, because these are the wheels on the other side of the car, so they need to be spun up. Okay, so what if I add this rotation from right? Right, I'm using the right one. And the roll angle. Okay. What happens if I just multiply this? Yeah, I don't think that's gonna work actually. And also, why am I applying a rotation and I'm not... Yeah, this... Let's just call it, yeah, I'm shadowing, I'm overriding the same. This is a very bad coding practice. What I'm doing is like, I have one value and then I'm just like assigning to the same value. Yeah, that's bad. So, yeah, let's just have let's call this base rotation. And then I can pass this into base rotation, right? Is this gonna work? No, maybe it should rotate along. I'm not sure. Okay, what if let's see. Okay, let's see what if I do this? Because it's this is using absolute, this is using world. So maybe that's the thing. That might be the thing. So let's just do this. And then instead of pi, I'm gonna say what was that? Spin something. Roll angle. Right? Roll angle. Okay. Okay. So this side is static, but this side is not. So yeah. It still is spinning completely. Yeah, it's spinning relative to the... but it is possible that... Should I maybe use identity here? What if... Okay, let's just try rotating like this without any special rotation. Yeah, the problem is that I need to add rotation onto each other. And do I actually do that? Okay, what if I put it here? I say rotation is this. Yeah, so first I do the roll. And then I rotate it. Okay, I don't know if this is gonna work, but let's try. I actually doubt it will work. Oh, it is spinning. Okay. Oh. Okay, it's working, except that the spin... Wait, well, I need to check on a slope. Let's check it on a slope. Maybe it completely doesn't work once you put it on a slope. No, the rear wheels are correct. But the problem now is, surprisingly, the rear wheels work, and they do spin, just in the wrong fashion. So yeah, the thing is that the only problem is that now the steering spins not relative to the car but relative to the world, which is it's this one. This is a steer. What if I use an up axis? I need to use from up because I'm converting bullet to GLM. This is the compilation of my game is almost the same as C# Unity, so okay, let's see. Okay, it's incorrect, still incorrect. So, what do we have to do? I don't know. Smooth steer the saddle. Okay. What if we not use the so rotate from, and then yeah, I'm not actually sure, but let me just check if the rotation is correct with both sides of the wheels, or is it spinning the other ways? So this one is spinning backwards, and this one is spinning backwards. So that's correct. Okay. So the only problem is spinning, which is it's not relative to the rotation of the car. It's relative to the spin. So that's the problem. We need to like unrotate kind of the spin or something. How do we do that? Okay, what if I do No, that's not gonna work. I don't think so. What if I do a spin first? No, the steer first, then the spin. Okay, well, that actually works. Does it? You're going backwards, you're going backwards. Everything is going backwards. Okay, so that was the secret, I guess. Just the correct and I actually, yeah, it's quaternions. Classic quaternions. You're just like spinning them around. Well, pun not intended. You're just switching the lines around, and then they work at some point. And then it's like, oh, I'm a genius. But actually, when I was thinking about this, I was like, no, it can't work. It won't work for sure. And then I just tried, and it worked. So yeah, weird, but I'm happy that it does work. So we have the spin. We can let's just increase the spin a bit. The 10 times, sure, but then I'm gonna minus it. Cool. Yeah. So we have a rolling car like this, and nice, it works. So yeah, if I go slow, it kind of looks realistic. But if once I go faster, you can see that the rotation is just constant and doesn't really care. So yeah, looks good. Looks good. It looks good when you're rolling slowly. Right, like this. Maybe slower, like this. Cool. First time I'm seeing spinning wheels in the game. So yeah, that's pretty awesome. Okay, so basically what I want to do is, instead of having obviously a constant roll, I want to put this to be relative to the, well, let's start by having there's a static float, and okay, so you can actually do this in C++, which is terrible. You can make a static float inside a function. Oh no. Okay, so let's put that in the physics car here. Float roll angle. So yeah, they're all going to have the same roll, right? That's a bit of a problem because they're all going to look identical. But doesn't matter for now. So yeah, roll angle, and let's not make it constant, but let's make the roll angle consistent with. Okay, let's put that in the physics. In the physics, I'm just gonna say here. Roll angle roll angle is, no, plus equals radius, turn radius, no, not turn radius, radius. Oh, I do have angular velocity. Oh no, that's angular velocity of the car. No, what I want is, first I want forward velocity, which is somewhere here. There it is. Forward velocity. And so when you're calculating the velocity that's of the car, that's wheel by radius. So so velocity is going to be, so yeah, the roll angle is going to be velocity by radius, right? Where do I actually get the radius? I think I have the radius somewhere. Turn radius. Wheel radius. Oh, it's actually a constant. Great. Let's just copy this for now. Or should I actually add it? Let's add that, since we're already changing here, as a member. So yeah, I don't need this wheel radius. And then I don't need this because it is now a member. I'm only familiar with the GameMaker programming, but the same principles apply there. If you don't know what the issue is, change the order of the code. Yeah, I think that rotations are the worst, because sometimes rotations just don't make sense. And yeah, the way that you multiply, it's kind of upside down. That's the problem. Okay, let's see. The car is not moving. The tires are not rolling. It starts moving. And there it is. Ah, it's moving, and it's moving really fast. Okay, so I think there's something wrong. So it's definitely moving a lot faster than it should. But they are spinning. So why is that? Is it right? Okay, let's see. So what the hell? Syntax error. No, I didn't want that. I wanted to make a new. Okay. So yeah, linear velocity is wheel by radius. Sorry, by radius. Like this by radius, right? So the wheel velocity should be, right, if I divide by radius, it is going to be linear. So no, my formula is correct. I'm a math genius. I need to write this down. So yeah, it should be correct that the wheel velocity is there a wheel velocity already? No. So yeah, wheel velocity should be this. Oh, right. Well, the problem is that I'm not calculating with, yeah, I'm not adding delta time. Of course, I'm an idiot. Delta time step. But yeah, it is, this should work. Just times it by 0, 1. Yeah, well, that would be hacking. But yeah, I forgot the delta time, of course. Every time you add velocity. Okay. So, let's see. Oh, it's perfect, except they're spinning the wrong direction. So yeah, they should spin in a negative. Okay, actually, let's turn this into rotation, because to me it makes sense that you should spin the angle increases when the wheel is turning towards the forwards. So we should actually do this. Where am I doing it? Here. Roll angle. So I'm just gonna minus it here instead of here. Okay. There we go. The wheels are spinning. They look correct. They're rolling perfectly. Nice. Yeah, they don't have any motion blur, which would be nice to add. But cool, we finally have wheel spin, which I didn't have for such a long time. Okay, now marvel my wheel spin until I make a very short break. Marveling in progress. Yeah, perfect. Okay, so we made progress. We made the tires spin. Amazing. Yeah, even to me it's kind of it's kind of amazing because I didn't have wheel spin for such a long time. Okay, so what is the problem now? Well, the problem now is that they're of course always rolling with the velocity of the car, which is not the case. That's you know, if you have how do you say, when you're sliding in place, right? That's not gonna work. So what I actually want to do, you see, if I try to like slide a bit, well, it almost doesn't exist. Slide doesn't exist. Although you can kind of do it if I reduce the grip. If I reduce the grip, you will actually, yeah, as you can see, you can hear it actually with the sound. I hope you can hear. With the sound, you should be able to hear that there is like, you know, the tires are squeaking. So that means that the tires are slipping on the ground. But the actual tire model that you can see doesn't reflect that. And here also, when I'm stopping, here the wheels are basically stopped. Alright? But it's still sliding. It's still like rotating. So what we actually want to do is we want to decouple wheels from the velocity of the car. And yeah, let's do this. But first I want to commit what we have so far. Let's not commit the config because I have this this starting position. Physics car. Yeah. Added wheel spin. Physics. Let's put it here so that I can see if I make some problem. Added wheel spin. Exclamation mark. Because why not? Okay, cool. So if everything goes wrong from this point, I can always revert to this place in time. Do you say place in time or time slice? I don't know. This moment in time, that's what I wanted to say. This moment in time where everything worked. Because now everything is going to go awful, right? Because we are going to turn our our engine from accelerating this whole car. So as I said in the beginning of the stream, right now in the old model, I'm literally just applying an impulse thanks to an input, delta time of course, and an acceleration multiplier, which is just a constant. So I have this constant, I'm just multiplying it, and in the end I'm just adding, I'm just multiplying these together here in this method. I'm multiplying. Yeah, I do say that it's obsolete already, but it's going to be obsolete soon. Yeah, and then basically I'm multiplying it and adding to the traction force. So to the sideways traction force. So we're going to change this kind of applying force directly to the car. We're going to change from that into applying force to the wheels. But I'm making a little simplification by making all the wheels spin together. So there's going to be no differential. There's going to be no transfer of power through the drivetrain. Instead, the clutch the clutch is transferring, of course, to the gearbox, but the gearbox is transferring the power, the impulse, directly to the wheels. So, how are we going to do that? Well, let's say that we have this parameter wheel velocity, right? We have this wheel velocity, and we have the roll angle. So, yeah, let's actually, for the beginning, let's make the wheel velocity, instead of having it here, like, affecting directly, let's just keep it. I'm gonna make the wheel velocity be affected by the acceleration impulse. Delta time step. So I'm adding, oh yeah, I can't do that because it's not a yeah, let's put this over here as a static value. Wheel velocity, let's make the wheel velocity like super tiny, just so that I can avoid this divide by zero. Classic. So now I can do this. So I'm adding impulse directly to the wheel. And this is probably going to be terrible. But let's see how it looks like in game with this, with just like where we can just see the roll angle spin. And let's actually remove this forward traction force so that my car is static. We should only see the wheel. We should only see the wheel spin, but not affect the physics. Okay, so let's see if I. Oh, there it is. Oh, of course, the engine is crackling because the engine is crackling because it's. Oh, right. Well, actually, to be honest, the transmission. Oh, right. To be honest, the transmission should add the velocity of the transmission should be exactly the same as the do I even have transmission here, or is that outside? Update action collision world. Okay. Let me remember. Velocity, drag multiplier, grounded points. Yeah, so there's basically no transmission here. force point. Yeah, this is yeah, this if is just if there's a grounded CT is grounded wheels count. So apply impulse. The problem is that I'm returning this force to the engine somehow, and I need to remember how I'm doing this. Apply torque impulse. No, that's for the car. Yeah, I think it's actually outside. It's actually here. Transmission. Oh, I actually have a separate script for that. I even forgot that. This is just the transmission element. But no, the actual transmission is somewhere here. Yeah, I'm building the drivetrain. And then, there it is. So yeah, I am coupling with the drive element, and drive element, there it is. This is the impulse from the road. And yeah, now I need to remember how I was doing this. So the drive element is actually the tires. Engine transfers the speed to the drive element, and then I do actually have some slip ratio here. Oh right, I am kind of faking the slip ratio. Maybe it should be, maybe the slip should be in the should be in here and not in the physics car thing. Yeah, maybe I think it's easier if I take it out for now. At some point I'm going to improve that, but let's remove the forward traction. And I'm not, I have the roll angle. That's okay. I'm going to keep it. But I'm not going to manipulate wheel velocity here. Instead, what I'm going to do is that in my main, I do have slip ratio, except this is the worst one. Yeah, it is better to use this one. Desired speed. Yeah, so I'm not calculating the wheel velocity. I do have some maximum. Interesting. Okay, I need to remember this. What did I do here? Actual speed. Yeah, so it is divided by actual speed. That's correct. Let me use this one instead. So this is going to be the actual velocity. And yeah, this is the actual velocity. And the ideal is P car wheel velocity by radius. That should be actually, it's called, I wrote actual velocity, but it's actually called actual speed. And it's not math, it's abs probably. It's fabs. Why is it fabs? What's the F for? I don't know. Okay, so we have the fabs, and okay, so that's the slip ratio. And then we have the longitudinal force, which is going to be, I don't have the Patseka here now. I have to copy that. From physics car, because I thought I would need it here, but let's actually copy it into the main. So we have it here. I'm going to use the slip ratio as I did here to calculate the force. Whoops, not floats. Even though it exists, right? Of course it exists. It's somewhere in the... Why do they do this? Why is there so many macros in the whole in the library? In all the libraries. Okay. Long force is Patseka simple. And then we have, yeah, let's do the same ones as I did in let's do the same parameters as I did here. I could have just copied, but okay. So we have the longitudinal force, and then what I want to do is I want to add that to the car. So I think, there it is, slip factor. I'm only using the slip factor. I see, from the table. So let's not use this. Instead, let's pass the acceleration input from the long force. This one. Okay, so maybe I do need to have forward traction force. So let's see what happens now. Let's see how terrible this is gonna be. And so how do I influence the speed of the wheel? I have to, let's see, I need the drive. Where am I mentioning the drive element? There it is. Oh, it's only in the pitch. Anywhere else? What? Oh, it's not even mentioned anywhere because I made a typo. Drive element in the source. Okay. Oh, there it is. No, that's only the setup. Okay. Transmission updates. Drive element. Desired speed. Oh, I am actually calculating the desired speed. I see. So the desired speed should be the wheel velocity, I think. Let's try to do this. Wheel velocity is desired speed, but divided by the radius. Wheel radius. Let's see how terrible this works, and it's probably gonna explode into infinity. Of course, as I imagined. It did explode. Perfect. Okay. So, what's the problem here? What's the problem here? Desired speed. Okay. Reverse is okay. Oh, I do actually have absolute speed here. So I don't need to use the fabs later. And I do have a velocity difference. That's how I used to calculate. By just calculating how much there needs to be. What's the difference between actual and desired? And then I added some slack. That's how I implemented wheel spin before. But now we're actually doing it over, trying to do over actual wheel velocity. Let's see. Let's output this wheel velocity. And then let's see what happens and why does it explode. Okay, so wheel velocity is 0 all this time. So does that mean if wheel velocity is 0, I'm okay. Does that mean the absolute speed? Yeah, if absolute speed is 0, it's gonna be super high, right? Um. Let's output the longitudinal force as well. It must be going crazy or something. What does it say? Oh, okay, it's going crazy. It's going crazy. Interesting. The thing is that I don't understand why is it even... Shouldn't the longitudinal force be 0 if there's no force? So if you pass 0, If you pass 0 to the Patseka, there's no division here, so this is gonna be 0 minus this is gonna be 0 and this is gonna be 0, so it should be 0. And why is it then this weird number? Okay, what if I add a little, if slip ratio is 0, long force is 0. How is this possible? Okay, so when I was adding force here, I was calculating velocity through, yeah, I actually had this multiplier. Slip ratio for sound. All right, I'm calculating for sound here. Let's move this up here, and I'm gonna multiply this by how much I did multiply down there. How much was it? This. Okay. What do the values say? Okay, it's still something, but tiny. Is it? Oh, it works. Yeah, I just had to put the I just had to. Oh wow, even slowing down works. Cool. Yeah, it's just the force is now, the grip is a lot like smaller. Should be a lot bigger, I mean. And let me actually output this. So car data. Yeah, so the thing is that I have this return force to the engine. And where am I actually doing this? Drive road impulse. There it is. Drive road impulse multiplier. It's a static. Nice. Okay, so it is a challenge how to calculate this drive road impulse now, but let's put it to something. Yeah, let's see what happens if I reduce it. Drive road impulse should be somewhere. Drive road impulse. Drive impulse. Oh, there it is. So if I put it something smaller, it should spin more easily. Nice sounds. Yeah, let me increase the multiplier here. For instead of 0.001, maybe 10 times higher. But it's good that it's already working. It's just that we have to make it work with the transmission and everything now. Okay. It is working. Super jerky. But it is working, kind of. Cool, even the gears work. It's just, it's way too grippy. And the cool thing is that the tires are spinning as they should. It's just that, yeah, I need to have a little less grip. Yeah, the problem is that the force that goes back to the engine, the reason why it's jerky, it's like the force going back to the engine is pushing constantly back and forth the tires, so there's this feedback loop. It's also way faster than before. Okay, so nice, thanks, Boan. So what if I put it to something like 002? It sounds sci-fi, yeah. I should probably move this into a multiplier. I do already have this grip multiplier, but yeah, let's... So the thing is that... Ah, there it is. Okay, yeah, the problem is that the engine is also preventing wheels to stop. So I have to go to... Yeah, now, to lock the wheels, I need to go into, like, neutral. Oh, I actually went into reverse. I see. But yeah, we can see now that I can actually stop the wheels, and the car is sliding and slowing down. So that's perfect. That's exactly what that's exactly how cars behave. As you can see here. Nice. And the deceleration is also linear. So it doesn't dig into the ground as it did before. So that's perfect. That's exactly what I wanted. The problem is, though, that... Yeah, I just need to balance the values. That's the only problem. Because yeah, of course, the steering... Don't look at the steering. It's completely... It's terrible. I'm gonna solve that another day. Now, today I'm just concerned with this. And of course, yeah, the problem is that when you brake... if you're in the first gear and you brake, the wheels will never stop completely because the engine is always pushing them forward, because they have there's an RPM limiter, right? So the RPM limiter is actually pushing it all the time. I would need to use the clutch. So if I press shift, it engages the clutch. So now it's completely separate from the engine. But once I release the clutch, the tires start spinning. So yeah, which is actually realistic, but in reality, the engine is at such a low RPM, is not that strong, so it will still, you know, stopping all the wheels will still stop the engine. You know, even if you have amazing technology to prevent that. So yeah, that's going good. Let's actually add this multiplier, this thing, into, yeah, what I actually, I want to try to do something. I want to add, I should have a little plotter somewhere. Is it a utility? I can't remember. Shader includes warning macros. What's that? I forgot. Oh, right. This is just to remove the warnings from the compiler. Instrumenter parser profiling. I did have something which, like, I had a table somewhere in one of these projects. I just need to find it. There is wheel rig. Maybe I had it here. Basic. Oh yeah, I was trying out Patseka here a long time ago. This is a more complicated Patseka. Calculate damping force. Slip finder. Oh right, yes, I remember this. Calculating ideal slip. I overcomplicated everything, but the thing is that I didn't really need to do that. Okay, so what do I? Where was this table? I had a table somewhere. Out floats. Plot function. NTK plotting plot function. There it is. Plot function. Plotting. Plotting.h. Where is plotting.h? Is it in my... There it is. Okay, so this is a little plotting helper I made. But I can't remember if I need to have... Yeah, I do need to have a window for that. So let's add that into my main. Let's use... include plotting. And now... where's my GUI? GUI. Slip table, torque table. Let's add it here, car data. Let's add it at the bottom of the car data, and let's see if... so, NTK plotting plot function. The function is going to be... shit, I forgot how you do lambdas in C++. Is it this one? Tire model, tire input. Okay, so what is this tire model thing? Okay, that's a function. Oh, I see. These are just captures. Um, so in my case, let's remove the captures. Instead, return. Right, I'm gonna return a Petseka. Simple. I'm gonna have a fixed FZ and the slip. The slip is going to be X. And now, that's it. And then after this lambda, I should have some more things. Plot offset, what is that? Plot offset, I think the plot offset is maybe 0. And what else? What are the other parameters? Plot offset, oh right, it's 0. Plot scale, it's probably 1, 1. It's not 1, 1, I don't know. We'll see. Color is... How do you get the color? I forgot. Okay, like this. And that's it. There's some other stuff. Size. Okay. So let's try this. Do I need to close the brace one more time? I shouldn't. Okay, there's something wrong here. Did I... Oh, right. I forgot this. Is that it? Expected a closed bracket. I see. Of course. Yes, this is from the imp color. I'm blind. So let's see if this plotting works. If not, I'm gonna figure out how to use the plot function. So basically what it gives me is that it gives me a little table where I can see the function. So yeah, if I go to car data, oh, there it is. Pfft. It's all over the it's all over the space, the window. Nice. Okay, so I can see the little peak over there, and then it goes flat. Oh, that's actually very peaky. Yeah. That's more like a tarmac, very tarmacy tire. But yeah, how do I actually draw it beneath? I'm not sure. Maybe I should just make a new window for just the plot. So yeah, by plot I meant like drawing a line of the function. Yeah, let me make a new window actually, just so that I can have show UI begin. Okay, I'm gonna put it here above imgui begin tire plot, or let's call it plot, and then imgui end, and then inside this thing I'm gonna put the plot function. And let me actually add a little slider. Slider float 2. I'm gonna make that the, what is it? What are the parameters? What is this thing? I think it's imvec. Is this an imvec? It is an imvec. Okay. So let's put a little imvec above everything. Let me put in parameters in game data. So instead of this, I'm gonna put plot scale, game plot scale. And here I'm gonna use a label scale, okay? And this is gonna be a plot scale, right? Game plot scale, which I'm gonna get a pointer to. And then you have minimum, yeah, I don't want a slider, I want a float 2, drag float 2, that's the one I want. Speed, let's make it 0, 1. And minimum is gonna be 0 or 0, 0, 0, 1 or something like that. Vmax, yeah. Okay. Let's try that. Let's see how the, oh, what is this? What is this? What is this? Incompatible with the type. Yeah, because I need a first value. It should be a float pointer. Okay, so here's my plot, which doesn't work. Nice. What's wrong? Right. it shouldn't be 0, 0. It shouldn't be initialized to 0, 0. Let's initialize it to 0, 1, 1. Yeah, let me actually shut down this wheel because I don't need it anymore. There it is. There's the plot. I can increase. Nope, I can't. Why can't I change the scale? One is wrong. Maybe the V was velocity and not. Okay, well, let's see. If this is velocity, V speeds. I'm not sure exactly. Okay, let's go with this. I'm not overriding it, right? No, I'm not. I'm not exactly sure what's wrong here. Okay, now it works. So that V speed was something weird. So, okay. I can, it lets me just modify scale a bit. But yeah, I should actually have different, I should be able to manipulate the vertical force as well. So let's try adding you know what? Let me add a little struct. Plot. Plot data or something like that. And I'm gonna make it a plot params. I'm gonna have a that invec 2. That's gonna be the scale. I'm gonna have a float, which is a FZ, that's 1000. And I'm gonna have the grip. Now what's the other, the slip is the other function, right? Maybe I'm just gonna have the FZ. What's wrong here? Expected, and oh, do I have to do it like this? Yeah, okay, so instead of having the struct outside, I'm gonna have it over here. And then we can just take that data, pass it into our UI. Instead of game, I'm gonna have plot params. Interesting. Plot scale, right. And I'm gonna have the drag float FZ plot params F yeah, it's actually just that. Let's make that 1 speed. Okay, so whoops, FZ, that's what I wanted. So I'm gonna pass this FZ instead of my static force. What does it say? Oh right, I'm not capturing it, so I need to capture it. You created a define shortcut for drag float up there. I did. I did, yeah, correct. Good that you noticed. I completely forgot about this. But I have it at 001 for some reason. It doesn't matter. It's just, yeah, the only reason I have these is so that I don't need to write the name. So it basically it uses the name of the value and then stringifies it and puts it in the string so that I can just say drag here. Hello, Pirxos. Nice to see you. But you're correct. Yeah, I totally forgot about it. It's like it's almost. I see these defines as like ads, you know, and I'm like ad blocking them. Okay, so let me take a piece of chocolate first. So we have the FZ now. I'm gonna see if this scales linearly or is there. I think it actually does scale linearly. Why doesn't this scale work? Wait a minute. Wait a minute. I didn't pass this. And game plot scale should be banned. Where it is. There it is. Why is this conversion always telling me something? Possible loss of data. I guess. Why is this possible loss of data? Okay. So if I reduce the FZ but increase the scale or decrease the scale, well, it's incorrect now. Shit, I can't. Okay, what if I increase and then I'm gonna increase the scale? Oh shit, I can't. Yeah, this needs to scale a lot more. Okay. Is it always the same? Well, it's not. Actually, it does. The scale does. You can see that the curve changes with FC, which is great, amazing. Oh, no, wait. I'm manipulating the X. Oh shit! I made a mistake. Okay. I should have manipulated the Y, not the X. I'm an idiot. Okay, so if I increase the FZ. No, let's decrease the FZ. If I decrease the FZ, is it the same curve? I'm just curious about this. Yeah, it is the same curve, so it's just multiplying, I think. Okay, so it's totally not physical, right? If I make the FC 1 and then I need to scale I need to scale it exponentially. You know that there is actually an exponential scale built into this somewhere. Vmin. Yeah, whatever. 0. Vmax 0. Is it? What the hell is Vmin and Vmax? Is there any documentation in here? Nope. Is Vmin and Vmax? Oh, that is actually a very nice. Oh, I like this. I like this widget. Okay, so is vmin and vmax just... is it velocity or is it value? That's the problem. Min and max bounds are broken. Okay, so I guess these are bounds. But this is min range and max range. I have no idea. Here's a bug caused by the fact that drag which do not clamp the value. This is an annual decision. It's the minimum maximum value. Hello, the holy moose. Okay. But what I'm confused about is why does it default to 0? Oh, well, look, there is the documentation inside. Okay. I just didn't look into this space. Okay, for all the syntax, they're expected to be accessible capacitor. Okay, well, it doesn't even mention what's... There's something below, but I can't scroll into that. Can I extend this? I can't even resize. There's obviously some text over here, but if I go to drag floats, well, there's no documentation here. So, I don't know. Where is it dragging the document? Where is it dragging this from? It's some kind of a separate documentation. Go to the header. Okay. Ah! The header. Drag scalar. Index of this file. I don't think this is the index. Long text. Okay, well, let's search for some widgets, drags. For all the floats to... Let's just search for all the floats. Well, it's not there. Go to the declaration instead. Go to declaration. Oh, right, there it is. Yeah, of course, I'm an idiot. I keep forgetting that C++ files have headers. I'm just used to like C#. You just put your documentation where the code is. Okay, for all the flow, just format string. Oh, yes, there it is. Use vmin, vmax to clamp edits to given limits. Know that control click can override those limits. Ah, so there's actually a control that slows down or speeds up or something. Clamp edits to given limits. But what I'm confused about is that use vmax float to max int max to avoid clamping to a maximum. The interesting thing is that the default is actually 0. Like it's 0 and 0, but yet it doesn't clamp to 0 and 0. So maybe if you put the 0 0, should it not clamp? Anyway, oh fuck, what is this format thing? Okay, a format. I see. It's just how many decimals you want. Let's do the default. And yeah, basically the reason why I was looking for all this is just so I can use the power, which is the last thing. Okay, so let's do a power of 2, maybe. But actually I wanted to apply this to this one. Okay, so it's a total this whole thing is totally off topic, just to help me like visualize things, but it's, yeah, I shouldn't have been doing this probably. And then you find these things that you just, yeah, well, learning C++. Okay, so well, the problem is that, okay, the power doesn't work. Or it does work. It does work. I don't think it works. Okay, so one, two. Oh, okay. I see. It works, but in the opposite way, I think. I'm not sure. Let's put a power. Let's put something crazy. Or let's put a negative power. What does the documentation say? There's nothing about the power. So basically what I want is for the slider, or for the drag thing, to be exponential. That's what power should do. It's still stepping by like 200, 100. I don't think this works. So if I go wait, which one did I change? Did I change the small one? Oh, great. Yeah, it crashed. So if I go to 0, let's say 1, it increases by 1. If I go super high, it still increases by 1. So yeah, the power thing is, I don't know, is it broken? Yeah, it doesn't matter. Anyway, what I want to do, though, is I do want to add a little slider into my plot function. I have to remember how I'm doing the plotting. What is it? Draw list. Right, there is a draw list. Beautiful. Okay, I need to obtain this draw list, and then push a line to the draw list. So what I want to do is I want to add a little line to this plot. So like this. See reference to function template t float. So yeah, basically what I want to do now is that when I use my tires, I want to see where the certain slip ratio is affecting the force, you know, in which part of the curve it is. That's what I want. So I want to make a little vertical line that points to this force. And that's I want to do with this draw list. Add line, right, you need to do that. Add line. And I'm gonna add line. So the x is from P to P. How do I get point or cursor position? Size, right, I have a size of the region, which is the window. Let's add that. I have the V size, what's the point? Point or cursor position. Right, that's the beginning, I think. Yeah, right, you're offsetting from there. +1 plus I. So yeah, I need to get this point as well. And then let's draw size of regions. Oh shit, I have these things. Oh, I can actually access them through NTK plotting size or region size. What's the size thing? Size. This is my custom. This is how I offset the plot in the window. Oh shit. I didn't know I can do that. I totally forgot. Okay, so because I'm using a separate window, I'm just gonna pass those null pointers to there. And that should work, hopefully. Haha. So yeah, let's add a line that is that goes from P, that goes from PX to PY, and then goes from PX plus 100 to PY plus V size Y. Right? And the color, yeah, let's actually make this white. And this I'm gonna make red. But this should be 0, and that's gonna be V size. Okay, and then let's put it plus 100. Okay, let's see if that works. So we should have a red line across the whole thing. There we go. Except for some reason the line is white. It's also white because I didn't make it red. But yeah, that should work. Okay, now let's offset it by the actual slip from my wheel. And that, how can I get the slip from my wheel? Because I'm not sure. Do I have the slip as a separate thing? There it is. Okay. So now I want to move this line with the slip. I think I'm just defining it somewhere here. Slip, slip, slip. There it is. Slip ratio. Okay. So let's move the slip ratio into the into this. So yeah, I am directly putting x as slip. Let's call it slip. And then there's my slip. So yeah, I don't have any multiplier for that. So I'm directly going to add this slip ratio. Slip ratio. And I should actually multiply it by the scale of the plot, right? Or divide. Do you divide? Or yeah, I should divide, right? Because increasing the scale, I'm not sure. I'm gonna check first. Okay, so we can see that the slip is somewhere there. It's at 0 basically. Yeah, now when I drive, the slip should change, but it's barely noticeable because slip is so small. So yeah, you can see that the slip is actually yeah, if I brake, let's see what happens. I think the slip goes below 0. Right. So yeah, the scale is actually increasing. So it should multiply. It should multiply. So slip ratio by plot params scale x. Add line. Let's put this into new lines so that it's more clear. And we also have to do to add this by plot params scale. That x lets me. Maybe I can put this into slip x. Slip plot x, let's call it. And then I can do this. Put it here. And then I have just 2 of these. Let me put this. Let x. A little nicer without this. Okay. So now, when I zoom in into my plot, I should be able to see. Okay. As you can see, interesting. What's going on here? I think it's going between the two, between the negative and the positive all the time. That's why it's kind of shaking. I will need to, yeah, well, of course, it's very slow speed. It's a bit unstable. But yeah, you can see here that in this region, over here, the tire is linear. The tire grip is linear, so the more the more slip there is, the more force there is as well, proportionally. And then once you go over the peak, you start to lose that. But it is still faster because it multiplies with the velocity. So Yeah, I'm pretty satisfied that it works. It's just that we need to... Yeah, if I have this FZ is 1000, maybe I can lower it. So yeah, this plot should actually be somewhere like 500 times bigger than it should be. 1000 times. Maybe 1000. Okay, so now we can actually see the peak. But it's going negative, so yeah, I actually need to absolutify this. And yeah, as you can see in this region, it's not really, it's still kind of on the peak. Yeah, so if I multiply the FZ, there's not much. Yeah, it is actually growing linearly. If I increase the plot, yeah, there's no difference. So it's not really load dependent. So I can just decrease it to like 1. And the grip will fall off proportionally. Just when you're going too slow. So yeah, I remember before I used to have these torque no, sorry, not the torque table. The torque table I still need. I had this slip table. So this used to be this. This is my old slip table where I would where I would manually move these up and down. But now I'm using the magic formula. So that's kind of a little bit simplified. I don't need to have this giant plot. And also, yeah, the problem with the plot is like, what do you do at the end? It doesn't continue to fall off. It just continues flat. And also, the linear section is too small. So yeah, much better to use the formula. But now what I can do is also I can put the formula values here. So let's actually move those to a separate struct. So let's call them Pateka params. And I have there's 4 of them. B, C, D, and E. And in the simplified version. And in where's my function? There it is. Right now I'm keeping them const. Yeah, let's actually put this struct over here. I'm just gonna have them float so that I can change them. And instead of just using this simple, I'm gonna pass Pateka params, except that they should be above. Let's call them P so that I can easily just add them. So the defaults are still there. Oh, fucking inline annoying inline. When you double press Control, it adds these inline arguments that are kind of annoying, especially when you have an auto. Like, the reason why I do auto is so that I don't have to write the whole thing. But it just decides, okay, well, yeah, use auto. So yeah, since I have this struct now, what I can do is I can add it to my, yeah, I need to add the params here. Okay, and the thing is that I can actually have, I can make them const reference, because they don't change anyway. That's one thing, and then also here I'm gonna pass Pateka params. And the cool thing, what is going on? Oh yeah, I'm not capturing them. I have to capture them. Okay, so they're in the capture. And the cool thing is that I can now add imgui drag float for take params. And I can pass this into the function. I don't even need to convert it because it's just this. And the speed, make it small, maybe. Yeah, make it like this. What is going on here? Oh yeah, of course, because we don't have this element, but we can add the first element. So I can modify them inside a single drag float for the whole struct. So let's try modifying them and see how the curve changes. Completed. Wheel spin. We actually completed wheel spin and longitudinal. Tire slip is already implemented, but can be much better. Okay. So, FZ, yeah, I could make the FZ like 1 or something, because, yeah. And Patseka param. Yeah, so if I change, yeah, I said that I want to make this the X scale 100. Okay, well, 200. Okay. So if I change the parameters, we can see that the curve changes. So this kind of offsets. This kind of scales horizontally. This changes the... oh, interesting. What's going on? It's not negative. So yeah, this makes the... What? Why does it start going backwards? This is weird. And it starts accelerating backwards. Okay. Strange. So now it doesn't want to stop even with locked brake. That's strange. So okay, this works, but for some reason increasing the peak. Okay, this decreases the peak. Yeah, this is the curvature parameter, I think. If I remember correctly. So, if I increase the curvature, in this region it should start slipping more than going forward. But for some reason, I have no idea why, if I increase it like this, it will go all crazy and will start going backwards at this slip. Interesting. Okay. I think that also, yeah, I remember I have some clamp somewhere, which I maybe should remove now. Slip ratio, let's see. Slip ratio. Yeah. Let's actually remove, let's make this the FC1. It should also be, it should of course be compatible. Yeah, let me make it const for now. So of course FZ should be dependent on the force from the ground, the vertical force. And I already have this force from the suspension. So I might actually take it from my car physics. But yeah, for now, let's keep it at 1, as if, you know, it's constantly being applied. And then I don't need this multiplier, such a huge multiplier. I can maybe just have 0.2. Or make a little multiplier for that as well. Let's add... Let's add that to game. Grip mold. I have a grip mold, but let's have a long grip mold. Starting at 0.2, which is longitudinal. And then somewhere I probably have the game grip mold somewhere. There it is. I'm gonna add this to be a long grip mold. So that I can modify it. Okay, so, and I think the slip ratio has a clamp somewhere, but I can't remember if I'm only using clamped for the sound. Slip factor. Yeah, I'm not using the slip factor anymore, I think. Drive road impulse. Oh. Yeah, this should be... Ah, I see. I was still using the old slip. Ah, that's where I made a mistake. I was using the old slip to return an impulse to the engine, and then but I was for the actual applying force to the car. I was using the new one. Cool, nice. I didn't even notice it. So yeah, I should have a. Let's call it the feedback factor. Not force feedback, but engine feedback. And let's call this a. Let's make it. The slip factor should be the same as the force, the long force. For now. Yeah, I do have a impulse multiplier. Actually. So yeah, the force returns to the engine here, and then in this next loop I'm recalculating. So let's see if that has completely fucked up everything. And here I'm gonna add the long grip mult. Should that be the total? Maybe it should. Okay, let's see this. And let's see the car fly into space. the moment the game starts, of course. Ah, it didn't fly into space. It's actually kind of working. So yeah, there is. It is coming back from the engine, the force. I think the grip is too strong now. Okay, so when the tire slips, it actually is, yeah, this is way too. Okay, so yeah, this FC, I'm going to use not the plot FC. Plot params FC. I'm not gonna use that FC. I'm gonna use. Actually, this is a constant. So let me change this FZ to 1 instead. And the plot scale is probably going to be tiny. Yeah, I do need to put it 100 here. And vertical is going to be super tiny, probably. And of course I also want to add the absolute. So yeah, this is wrong. The scale should be more like 300, eh? Okay, let's go with 300. for y 300, and let's absolutify the inputs. Where is it? Plot function, parameters. So here, no, not there. It's actually here. When in that line, I want to make this fabs so that the line doesn't go across to the other window. But I do want to make it a different color when it's negative. So let's make it in color, line color, slip line color. And it's going to be if slip ratio is more than 0, I'm gonna make it red. Otherwise, I'm gonna make it the opposite of red, which I'm not exactly sure what it is. Is it yellow? No, it's not yellow. It's cyan. Yeah, I think it is. No, it's not. Red, green, blue. Green and blue. It is, yes. It is in between cyan. So yeah, if it's more than 0, red. If it's less, cyan. And then I'm gonna use this, plug it in here. Let's see if that works. And we can see that it's flipping from negative and positive because it's like it's so unstable here. Oh, and the grip is so tiny now. It's ice. Can't even go forward. Okay, so now I need to increase the grip a bit. The forward grip. So, where is my longitudinal grip? Okay, if we increase it, let's see what happens. Yeah, it stays in this linear range, but it's also bouncing a lot. It's porpoising. That's what it is. I just made the car the same as Formula 1. You can see that it's shaking all the time. So my engine is perfectly replicating the same problems that F1 has. Such a good simulator. Okay, so it's constantly in the linear range now with the high grip. We want it to go a bit off, but also maybe I should, like, if I reduce Oh wow, it just flew over. Okay, let's reduce the grip. And also, this, where is this engine thing? Engine. Can't even find it anymore. What was the name of it? Something... And... Feedback. Feedback fact, drive road impulse multiplier. Drive impulse. Oh, that's drive impulse. Okay. So if I reduce the drive impulse, yeah, now it's much easier to like slide around. Nice. So now it makes sense, except that it's quite unstable. But that's okay, you know. In video games, you can solve any instability by just doing 1,000 iterations. 1,000 sub-iterations. Yeah. And that's how you solve things. No, I'm joking. I'm gonna have a special case for like low speed program. This is cool. So now we are sliding. We're sliding the wheels, and even braking is more realistic because I can. But I need to hold the clutch. As you can see, the tires completely slow down up to zero speed, and then you have this grip. Okay, so if I increase the curvature, so yeah, now it takes such a long time to brake because it loses this grip after the peak. And also sliding produces a lot less force. Wow, it's like in 6th gear or something right now. Yeah, you really need to keep it in the peak. So it's kind of like Formula 1 car now. Yeah, unless you keep it in the peak, it's just gonna slip over. And once you start spinning your wheels, there's no coming back. Yeah, you can go into like the 6th gear and you're just like spinning wheels into nothing. Okay, so yeah, rally car definitely needs to have lower curvature. And you know what would be cool? It would be cool to make blurry wheels as well. You know, like classic games that change the texture of the wheel. I might do that next time. But yeah, I'm pretty satisfied with this. It just needs to, I need to tweak the values. It's way too powerful now. Whoop. No. Yeah. So what are the other parameters? I didn't even... Okay, this is vertical scale. And what is this? Oh, shit. I have no idea what's this. Oh, it's going backwards. It went into negative. I should probably clamp. Should probably clamp the vertical. You can clamp the force to the biggest possible value in the given delta time. It will get rid of overshooting at still or low speeds, since it won't go from positive into the negative when the grip is high. Yeah, I've actually seen this before. I've seen this being done in the given delta time. Yeah, I might do that. But yeah, for now, at high speed at least, it looks nice. I just need to find some good values. So the thing is that you should be able to, like, when you're in first gear. Yeah, this shouldn't happen. So I'm holding shift, so it's like completely still. You see, but it's still going forward somehow. Okay. So yeah, wait, I need to change the manual. So when you're in like the first gear, and then I release the clutch, you should be able, you should spin the wheels, right? But yeah, it's too grippy now. So I do need to reduce the grip. And where is the grip? No, this is the engine. And the grip. Yeah, if I reduce it to like 0.1. There it is. But now it's a bit it's a bit too slidey. Yeah, even like when it's locked. So yeah, there is some balance to be found, also playing around with the curves. But yeah, I'm pretty happy with how this conversion took. Whoops. I can reduce the size of this so I can see the parameters more clearly. Yeah, this is way too slidey as well. When you spin around... Yeah, I am pretty sure that the rally cars should have a less curvature. Like this. Look, I'm going at fifth gear. Okay. So yeah, maybe the grip is too small. And now it's all about... Okay, let's make the grip super... Oh no, not that grip. That's sideways grip. This is a longitudinal grip. Yeah, if I make the grip too small, if I make it too high... Oh, what? It's moving sideways. It's because I was messing with this sideways grip. Must be. Cool. Now I'm going... Now this is a challenge. Now we can play the game like this. Oh, let's do a jump. Come on. Yes. There's a jump. This is like this is totally drifting. Cool. What the hell did I do? I think I messed up completely everything when I accidentally put the grip to minus. That's nice. Strange. Okay. Anyway. Let's see. So, did I make any? Yeah, it's almost 3 hours of streaming. I think I'm gonna probably finish in like 10 minutes or something. Uh, but yeah, it was interesting day today. Changed the physics completely. I just need to make sure it's smaller. So what Pixos is saying, clamping the force to biggest possible value in the given delta time. But how do I actually find the biggest possible value? What's the biggest possible value? Delta time by current grip force. Clamp the force, but I'm already doing that. Am I not? Because the way that I add, I mean, I'm just adding. Where is it? Yeah. Here, I'm passing to my physics car, I'm passing the acceleration. But the acceleration is nothing more than just. Where's my implementation? Nothing more than just multiplying with this acceleration impulse. All right, wait. I just realized something. So I have the wheel velocity. Desired speed. Wait, shit. Oh yeah, right. It's drive elements. Right. It comes from the engine. So the engine passes through the transmission and passes the speed. Maximum wheel velocity. Oh yeah, that's for a transmission calculation. So it wants to achieve the speed, right? And then yeah, I know what the speed of the wheel is, and then I'm using that to calculate the slip. And then, yeah, and I have this special case where the speed is 0, then the slip should be 0. And then the longitudinal force is 0. Automatically, it should be 0. Fz is 1 by default. And then when I get this data, I multiply it with the grip, pass it into the acceleration, which just adds force to the car. Slip ratio. Oh yeah, I do have this limit, but it's not actually used for anything. It's only used for the limits. The limiting is actually only used for sound. Yeah, I also have these particles, which I'm not using at the moment. Yeah, actually, the problem is that I'm clamping the slip for effects. And then that get passed to the GUI, which is terrible. It's just like I need to output this slip, but it's going into the GUI. So let's just make a slip ratio for effects instead of clamping it here. So wherever I need the slip ratio, slip X. What the hell? Slip lookup scale. I don't need this anymore, right? I'm pretty sure. Okay, so where... Oh, I have slip ratio for sound already. Right. Let's call this clamped. And wherever I have the slip ratio, I'm gonna add... I have some more effects here. Yes, this is for particles. Let's use the clamped. Although I have to redo particles as well. Clamped. And clamped. Okay. So now the plot will show the correct unclamped slip ratio. Which is still here somewhere. It's going from 1 to -1. All right. So yeah, I did actually probably use clamped ratio for something. Because... Well, it still clamps to here for some reason. Oh no, actually that's okay because... Yeah, right. The tires are still, which means that the slip ratio is 1. Yeah. That's the point of slip ratio. The slip ratio goes over when the tire is spinning faster than it should be. If it's still, then it's always 1. So yeah, it definitely has to be more grip multiplier. Where's my longitudinal grip? Let's make it double. That's not bad. What if I offset? Oh yeah, right. Now I'm going backwards. Oh, amazing. Cool. Yeah, it has exploded into infinity. Okay, it's coming back. So yeah, it definitely, the peak should definitely be shorter than 1 because it doesn't make any sense to have the linear parameter when it's okay. Oh, this is actually the grip multiplier. And this weird thing is so weird. Yeah, and I should definitely not have a negative for a... Okay. So yeah, the longitudinal force should not be negative when the slip ratio is positive, right? I think so. I can do just this. A stupid way to clamp, but I could have just added an or, but yeah, for now, let's see if that even makes sense. So, if I put, yeah, now if I do this, it shouldn't explode, it should just slide. Okay, that's good. That's good, we're sliding. We're not exploding. At least something successful. Oh, wow, what the hell is this? Okay. Definitely bad. Okay, so now it's sliding forever. But it's not exploding into infinity, which is good. So yeah, let's decrease the curvature. Okay, so if it is... Oh. Yeah, it has gone below 0. That's somewhere in the future. Because of fiddling with this parameter. So yeah, if it is constantly linear, then there's a lot of grip. And it is still exploding. Okay, anyway. So, how about we try to fix instability by just doing multiple substeps? Sorry. The clamping, it's a bit more complicated. Max force is force that will stop the wheel in current delta time. The will. The willpower. I'm not sure exactly what you mean. But yeah, anyway. I think I figured some things out. And yeah, I'm glad that the slip ratio works. Let's try this in the spinning wheel. Let's try this in game with the... Oh, fuck. We fucked up. Okay, well, where's my... I don't need this. What the hell is this? I don't know. Let's do a Monty, but this one. Oh, it is Monty. So what's wrong with the start position then? Bin release. Why is it underground? Is it Monty? Where's Monty? Where are you, Monty? Was there any bug? What does it say? Does it say failed loading or something? Failed to read file. Monty Road. What the hell? Oh no! Oh no. So. No, I didn't want that. I wanted this. Does Monty Road work even? Failed to parse. File is empty. What the fuck? What happened? File is empty. How did that happen? What? Monty Road is 0. Okay. Pfft. Did I incorrectly output something, or did I accidentally override it with an empty file? Interesting. Okay, let's go to the track. Here's my beautiful track. Okay, let's re-export it. Monty Roads. No, not that one. Wrong. No, it should go to models, Monty Roads. Okay, it's 25 megabytes now. Okay, there it is. So let's try to drive with the new grip. So slow. So much slip. But hey, at least the wheels are spinning. Let's increase the longitudinal grip. Okay, drivable. Braking works, but for some reason acceleration doesn't. Okay, well, let's call this stream successful. A lot of things to tweak, but at least I managed to, like, well, there is a lot of vibration, and for some reason it gets locked in the first gear, but at least we can, like, slide our wheels now. I don't know what's going on, like I'm pressing the throttle. It doesn't actually like the linear part. I'm gonna have to test more and just tweak the values. Also, one of the problems is that this thing, the whole slip thing is running inside. Oops, what did I do here? It's running inside inside rendering. So yeah, depending on how high your FPS is. So I need to move that to physics, to the physics loop. Yeah. And I just fell off. Nice. So cool. Okay, at least we have some wheel spin. Like you can brake with the wheels stopped. As you can see here. Cool. And actually the sound follows even if I didn't touch the sound at all. Probably the drive should also, there should be less feedback to the drive, so that I have some wheel spin. Maybe even less. Okay, let's try reducing it even more. Nice. Way too fast now. Yeah, the problem is that because the road is not giving me any feedback. If you reduce the feedback impulse, by feedback impulse I mean the force that the road gives back to the engine, then the car just starts flying really fast because there's little to push it. So the thing is that I should actually reduce the grip of the tires and not decrease the drive much. But yeah, it's all of these parameters that you need to balance. That's the thing. You have the feedback force, you have the force of the wheels that are giving the linear, you know, velocity to the car. And then you also have the grip. And they all need to be balanced. Here, completely locked wheels. And now there's too much grip for locked wheels. Or too little grip. So it should actually be a little bit more, you know, like this, maybe. So when you brake, yeah, still needs to be more grippy. But when you slide the wheels, it should slide more. I mean, not when you slide, but when you step on the gas. Like this, and then release. Yeah, this is way too little grip. So, the... yeah, the problem is that at very high slip, if it's rotating like 1,000 times than it should, then it's almost zero. Then there's almost no force. But there still should be some force. That's the thing. Not zero. So there's a lot of balancing to be done. But yeah, now there's too much grip. And then the car flies away. And yeah, what about the brakes? Am I actually using... Where is brake? Drive road impulse. Oh, I am actually manipulating the drive road impulse from the brakes. Whoops. I should remove that because I'm only influencing the wheel speed now with brakes. They shouldn't influence any external forces. Yeah, anyway. I'm thinking about 10 different things at the same time. So yeah. It's so hard for me to keep up with just talking as well. Thinking about physics and everything. But yeah, successful day. I just need to find some good tweaked values. Way too fast now. And also, the brakes shouldn't be strong enough to cause an instant stop. And then I would need to implement ABS as well, which I don't want. But yeah, if I can't tweak, the good thing is that if I can't tweak these values, I can always revert back to the old one, which didn't have wheel spin. Whoa. It's a rocket. Whoa. Too easy to crash. So yeah, Okay, let's do a opposite, reversed. So yeah, that's about it. When it comes to the stream. Tomorrow, tomorrow I'm going to work on more 3D things, so that I can have some nice screenshots Saturday. Prepare like yeah, I'm gonna make all these props that I was always delaying doing, which includes like rally stuff, rally signs and traffic signs as well, and some chairs, tables, you know, flower pots to populate the town, some electricity poles and telephone poles and stuff like that that I can put around, and maybe even some trees, except that's gonna probably involve goodbye. That's some trees is gonna probably involve a completely separate stream. But yeah, wow, it's so creepy now. Whoa! I don't understand why some houses don't have any physics. I'm not exactly sure. So these have... This fence has... The church has... The church is collidable. But some houses don't. Hey, did I just call them tree? No, they're just houses. Interesting. Okay, then I don't know. There is some bug. Okay. So yeah, tomorrow 3D again. And then hopefully after tomorrow there's gonna be everything else that I do is only going to be codes. Oh, and I also need to make the intro. Yeah, which I don't know if I'm gonna have time for, but hopefully after tomorrow everything is gonna be yeah, code and tweaking. Tweaking everything. Tweaking the colors, the 3D models maybe, and tweaking the car physics. So yeah, that's about it for the stream. I'm leaving you with the upturned car. Thanks for being here again, and see you tomorrow. Goodbye.